Hello everyone. Welcome to our another video in the series on mastering data structures and algorithms. I'm Dr. Prashant Gupta. In the last video, we gave an introduction on the linked list and gave a very small example on how to create a linked list and add one node to it. So let's dwell upon the idea of the linked list further and let us see what are the basic operations that we can perform on the linked list. This is a brief introduction about me. There's a link to my website that contains all the information about me, including my publications, my patents, my international visits, and now I have also started making available on my website the PPTs to the lectures that I am delivering over here, the links to the explanation videos, as well as the C programming codes for the topics that I am discussing in these lecture series. My passion is research and teaching. So let us talk about the first operation that we can perform on the linked list, that is the insertion into the linked list. Now there are these possible cases, case 1, case 2a, case 2b, and case 3. Wherein case number 1 talks about when the insertion of the new node is to happen at the beginning of the linked list. The size of the linked list can grow on and on. However, every time a new node is added is always at the starting of the linked list. Now there may be various conditions that will be guiding this. Case number 2 occurs when we have to insert a new node at a specific location. Now this is case 2a where the insertion can take place when the linked list is unsorted, or case number 2b occurs when the linked list is sorted. And case number 3 occurs at when the insertion is taking place at the end of the linked list. Let's see. So the topic of this video is case number 1 only, when every time a new node is added is only at the beginning of the linked list. Let us first of all try to understand the algorithm and its working through an example. Let's see. Let us call our procedure as insert begin, and we have these data values as input: start, new, and data, where data is the value of the data item that we want to insert into the new node. New will be, as discussed in the previous video, will be a new pointer that will be allocated the memory dynamically. It will be getting the value data, and then start is the pointer that contains the address of the first node in the linked list, also called the header node of the linked list. And link will be pointed to the next node from the new node that we are inserting into the linked list. And the steps are pretty straightforward and simple. We have to simply allocate the memory to the new pointer. We have to set the information and link part of the new pointer and assign the value of new to the start node, and our algorithm exits. Let us see this working. Let's say our linked list is in this form where we are given the start node. We have the first node that contains the information in the link part whose address is contained in the start node over here, and so on till the time we have a last node where it is identified with the information part and the link part is null. So the result of allocating this first step is simply allocating the memory to this new node where it contains an information part and a link part. The next statement causes the data value to enter into the information part, as you can see over here. In the next step, we have the value of the news link assigned to the start, like over here. And finally, in the last step, the start is assigned the value of the new. Therefore, this link over here, as it is shown by the dashed line, ceases to exist, and now start points to this node, and therefore the path taken by a linked list becomes like this. Now over here, there is a very important point to note. This order of these two instructions is very important. We cannot execute instruction number 4 before instruction number 3, or another way of saying it is not at all possible to interchange these two instructions. Because in case if we do that accidentally, that is, we first allocate the address of the start to the new. So in that case, without assigning this link, in that case, our address of whole of the linked list will be lost from here. Therefore, this order is very important. Let us see the C programming code, which is very simple and straightforward. So these are the header files. And in the last video, I talked about a header file that is stdlib.h and also told you that instead of that, we can also make use of the malloc.h. This is the structured declaration for the linked list. We have our main function, and as in previous video, over here also we have created two pointers, new and start. A start holds the address of the first node in the linked list. Now, this first instruction allocates the memory to the new node dynamically. Now we are asking the user to provide the data values to enter into this new node. Now, these instructions are straightforward conversion from here to here into the C program. You can see we are simply assigning the new data value to the news information link. Now, there is a slight difference in the last video and over here. In the last video, we allocated the null value to the new link, but over here it is allocated the value of the start, which is the address of the first node in the linked list, and then start is assigned the value of new. Therefore, in this way, we repeatedly can enter a new node into the linked list at the beginning of the linked list every time. Thank you all for watching this video, and don't forget to subscribe to our channel for more and more good videos that will be coming up soon. Thank you.